Good morning, children. Today, let us start the numericals. Before start the numericals, let us recall the formulas. The speed of the object, the speed of the object is equal to the distance travelled by time taken. That is, V is equal to S by T. V represent the speed and S is the distance and T is the time taken. Next, the average speed. The average speed is equal to the total distance by total time taken. Then the velocity of the object. The velocity is same as the speed of the object, that is V is equal to S by T. Then the acceleration. A is equal to V minus U by T. A is the acceleration, V means the final velocity, U is the initial velocity. Then the average velocity, when the velocity of the object changes at uniform rate, then it is given by the arithmetic mean of the initial and the final velocity. So when the velocity of the object changes at uniform rate, then the average velocity is V plus U by 2. And the equations of motion, the first equation of motion is V is equal to U plus AT. Here V is the final velocity, U is the initial velocity, A is the acceleration and T is the time taken. Next, S is equal to UT plus half AT square. This is the second equation of motion. S represents the distance travelled, U is the initial velocity, A is the acceleration. And the third equation of motion is V square minus U square is equal to 2AS. First problem. The minute hand of a clock is 7 cm long. Calculate the distance covered and the displacement of minute hand of the clock from 9 AM to 9:30 AM. Here, the length of the minute hand is nothing but the radius of the circle. Here, let R is equal to 7 cm. Then, at 9 o'clock, the position of the minute hand is at 12. At 9:30, the position of the minute hand is at 6. So, when the minute hand is moving from 9 to 9:30, it covers the half of the circumference of the circle. Half of the circumference of the circle. So, the distance covered by the minute hand, distance covered by the minute hand, from 9 to 9:30 is half of the circumference, of the circle. So half of the circumference is pi r. Then pi is equal to 22 by 7. The radius is 7 cm. Cancel the 7. So the distance covered by the minute hand from 9 to 9:30 is 22 cm. And the next, find out the displacement of minute hand. Displacement of the minute hand. See, so initially the position of the minute hand is at 12 o'clock, but at 9 AM the initial position of the minute hand is 12. At 9:30 the final position of the minute hand is 6. So the distance between the initial position and the final position is nothing but the diameter. So the displacement of the minute hand from 9 AM to 9:30 AM is the diameter of the circle. Diameter of circle. So the diameter of the circle is 2r. Here the radius 2 into the radius is 7. So 14 centimeter. So the displacement of the minute hand from 9 AM to 9:30 AM is 14 centimeter. Next problem. After studying the motion of a ball rolling on a straight line as shown in figure, find the distance and displacement when it rolls from A to B, B to C and A to B and B to A. The distance covered by the ball when it rolls from A to B and then B to C is AB plus BC. Distance covered by the ball from A to B and B to C. B to C is, so when it rolls from A to B and B to C, the distance covered is AB plus BC. AB is 10 meter and BC is 2 meter. So 10 plus 2, 12 meter. So the distance covered by the ball from A to B and B to C is 12 meter. And then displacement. See, the displacement is when it is ball rolling from A to B and B to C, A is the initial position and C is the final position. So the displacement is AC. So AB minus BC gives AC. AB is 10 meter, BC is 2 meter. So 10 minus 2, 8 meter is the displacement. Next, the distance covered by the ball when it rolls from A to B and B to A. Next, distance covered by the ball from A to B and B to A, we can write it as A to A. So when it is rolling from A to B and B to A, the distance covered is AB plus BA. AB is 10 meter, BA is also 10 meter, 10 plus 10, 20 meter. So the distance covered by the ball from A to A is 20 meter. Next, displacement from A to A. Displacement from A to A. Here, see, the initial position is A and the final position is also A. So when the initial and the final position of the object is same, then the displacement is 0. So AB minus BA, AB is 10 meter minus 10 meter. So the displacement is 0. When the ball is rolling from A to A, the distance covered is 20 meter and the displacement is 0. Next problem. Neha travels 4 meter towards north, 3 meter towards east and then 7 meter towards south. Find her displacement and distance covered. Let the initial position of the Neha be A. She travels 4 meter towards north and then 3 meters towards east and then 7 meter towards south. So D, A is her initial position and D is her final position. Join AD. AD is the distance between initial and the final position. So that is the displacement. AD is the displacement. And the distance covered is AB, BC plus CD is the distance covered by the Neha. So the distance covered is equal to AB plus BC plus CD. AB is 4 meter, BC is 3 meter and CD is 7 meter. So the distance covered is 14 meter. Next, find out the displacement. See, when she moves from A to B, B to C and C to D, here draw AE perpendicular to CD, then AB is parallel to CE. AB is parallel to CE means AB is equal to CE. CE is also 4 meter. And then BC is equal to AE. BC is 3 meter. AE is also 3 meter. And then CD is 7 meter and CE is 4 meter. So ED is 3 meter. Now find out the displacement. To find the displacement AD, we have to consider the right triangle AED. We know AE, we know ED. So by applying the Pythagoras, find out AD. In triangle AED, angle E is equal to 90 degree. Therefore, AD square is equal to AE square plus ED square by Pythagoras theorem. AE is 3 square, ED is also 3. 3 square is 9 plus 9, that is 18. So AD is equal to square root of 18. We can write it as 9 2s are 18. The square root of 9 is 3 root 2 centimeter. So we can substitute 1.414 in place of root 2. 3 into the value of square root of 2 is 1.41414. So multiply 3 into 1.414, that is 4.242 centimeter. So the displacement is 4.242 centimeter. So the distance covered by the Neha is 14 meter. The distance covered by the Neha is 14 meter and the displacement is 4.242 meter. Next problem. A car travels 30 km at a uniform speed of 40 km per hour and the next 30 km at a uniform speed of 20 km per hour. Find its average speed. Here the two distance and the two speeds are given. Let S1 is equal to 30 km and speed V1 is equal to 40 km per hour and S2 is equal to 30 km and V2 is equal to 20 km per hour. Then find out the average speed. You know, the speed is equal to distance travelled by time taken. Then V1 is equal to S1 by T1. Then T1 is equal to V1 S1 by V1. The S1 is 30, V1 is 40, cancel the 0. So the T1 is 3 by 4 hour. And next V2 is equal to S2 by T2. Then T2 is equal to S2 by V2. S2 is again 30 km and the V2 is 20. Cancel the 0. So T2 is 3 by 2 hour. Now you got the T1 and T2. Find out the total time. T1 plus T2. T1 plus T2 is equal to 3 by 4 plus 3 by 2. So take the LCM. The LCM is 4. So 3 plus 3 2s are 6. 3 plus 6 is 9 by 4. So the total time is 9 by 4. Therefore, the average speed is equal to S1 plus S2 by T1 plus T2. So the distance S1 is 30 plus 30. The total time is 9 by 4. So 60 into, take the reciprocal of 9 by 4, that is 4 by 9. 3 3s are 9, 3 20s are. So 20 into 4, 80 by 3, divide 80 by 3, it divides 26.6 times. So the average speed is 26.6 kilometer per hour. Next problem. On a 120 kilometer track, a train travels the first 30 kilometer at a uniform speed of 30 kilometer per hour. How fast must the train travel the next 90 kilometer so as to average speed 60 kilometer per hour for the entire trip? Here the 120 kilometer track means the total distance is given. Let S is equal to 120 kilometer and a train travels the first 30 kilometer at a speed of 30 kilometer per hour. So let S1 is equal to 30 kilometer and V1 is equal to 30 kilometer per hour. And the average speed of the train is given, that is 60 kilometer per hour, and the next distance is 90 kilometer. So let S2 is equal to 90 kilometer. So you have to find out the speed with which the train travels along S2. So find out V2. Now by using the average speed, find out the total time taken first. Now average speed is equal to total distance by total time taken. The total distance is S1 plus S2. Let the total time taken be T. S1 is 30 plus 90 by T. The average speed is given, that is 60. 60 is equal to 120 by T. Then take cross multiplication. T is equal to 120 by 60. 60 ones are 60 twos are. So the total time is 2 hours. Now you know the speed S1 is given, that is 30 kilometer. V1 is given 30. So find out the T1. Therefore T1 is equal to S1 by V1. The S1 is 30 and V1 is also 30. So the T1 is 1 hour. T1 is 1 hour. Now find out the T2. T2 is, if you subtract the T1 by the total time, that gives the T2. T minus T1. T is 2 hour and T1 is 1. So T2 is 1 hour. Therefore V2 is equal to S2 by T2. S2 is 90 and T2 is 1. So V2 is 90 kilometer per hour. So the train travel with the speed of 90 kilometer per hour in covering the next 90 kilometer. Next problem. A scooter acquires a velocity of 36 km per hour in 10 seconds just after the start. It takes 20 seconds to stop. Calculate the acceleration in the two cases. Here in the first case, a scooter acquires a velocity of 36 km in 10 seconds. Here the velocity is given and the time is 10 seconds. So case 1. After the start means here the initial velocity is 0. Let u is equal to 0 and the time is 10 seconds. 10 seconds, and the velocity is given v is equal to 36 kilometer per hour. Here the time is in second and the velocity is in kilometer per hour. Convert the kilometer per hour into meter per second. So 36 into 1 kilometer is equal to 1000 meter, and 1 hour is equal to 3600 seconds. Cancel this 36 ones are. So the velocity is 10 meter per second. So 36 kilometer per hour is equal to 10 meter per second. And then find out the acceleration. You know the acceleration. Acceleration is equal to v minus u by t. V is the 10 meter per second, 10. Then initial velocity is 0, and then time taken is also 10 seconds. So 10 by 10, that is 1. The unit of acceleration is meter per second. So the acceleration is 1 meter per second square. In the second case, case 2, the scooter takes 20 seconds to stop. It means here the initial velocity we will consider the 10 meter per second, and then the time is 20 seconds. After 20 seconds it comes to rest. It means the final velocity is 0. Find out the acceleration. Then acceleration is a is equal to v minus u by t. Then v is the final velocity is 0 and initial velocity is 10. The time is 20 seconds. So minus 10 by 20. So 21s are 2s are. So if you divide 1 by 2, you will get minus 0.5 meter per second square. So here the acceleration is minus 0.5 meter per second square. Thus the negative sign represents the retardation. Next problem. A car increases its speed from 20 km per hour to 50 km per hour in 10 seconds. What is its acceleration? Here the speed is given. The car increases its speed from 20 km per hour. It means the initial speed is u. Let u is equal to 20 km per hour, and it increases to 50 means the final velocity or the final speed is 50 km per hour, and the time is given, that is 10 seconds. Find out the acceleration. Here the time is in seconds and the speeds are in kilometer per hour. Convert kilometer per hour into meter per second. So 20 into 1000 by 3600. Cancel this 20. Next 2 5s are 2 18s are. Next 2 9s are 2 10s are. So 50 by 9 meter per second. So the initial speed is 50 by 9 meter per second. Then the final speed, that is 50 into 1000 by 3600. Cancel this 0. Again 2 5s are 2 18s are. Next 2 9s are 2 25s are. 25 into 5 is 125 by 9 meter per second. Now you got the initial and the final speed. Next, find out the acceleration. Therefore, acceleration is equal to v minus u by t. The final speed is 125 by 9 minus initial speed is 50 by 9. Then the time taken is 10. So here the denominators are same. We can subtract the numerator. 125 minus 50 is 75 by 9. So take the reciprocal of 10, that is 1 by 10. Next 5 2s are 10. then 5 15s. Next 15, we can divide 15 and 9. 3 3s are 3 5s. 5 by 6, divide 5 by 6, it divides 0.83 times. So the acceleration is 0.83 meter per second square. Next problem. A moving train is brought to rest within 20 seconds by applying brakes. Find the initial velocity if the retardation due to brakes is 2 meter per second square. Here, a moving train is brought to rest within 20 seconds. Brought to rest means here the final velocity is 0. Let v is equal to 0 and the time is 20 seconds and the acceleration is given. The acceleration is retardation. Retardation means it represents the negative acceleration. A is 2 meter per second square. Find out the initial velocity. Next, now by applying the first equation of motion, we can find out the initial velocity. You know the first equation of motion, v is equal to u plus at. So v is 0, you have to find out, write as it is. In place of a, substitute -2 and the time is 20. So 0 u minus 40, therefore u is equal to 40 meter per second. Therefore the initial velocity of the train is the initial velocity of train is 40 meter per second. Next problem. An object undergoes an acceleration of 8 meter per second square starting from rest. Find the distance travelled in 1 second. Here the acceleration is given. Let a is equal to 8 meter per second square, and so the object starting from rest means the initial velocity is 0 and the time is given, t is equal to 1 second, and you have to find out the distance travelled. The distance travelled is yes. Find out the distance travelled. Here the acceleration is given, the time is given, and the initial velocity is 0. You have to find out the distance travelled. Here we can apply the second equation of motion. Now s is equal to ut plus half at square. This is the second equation of motion. The initial velocity u is 0 and the time is 1 plus half into acceleration is 8, then t is 1 square. 2 1s are 2 4s are. 1 into 0 is 0, then 0 plus 4 is 4. Therefore the distance travelled is 4 meter. The distance travelled by the object in 1 second is 4 meter. Let us continue in the next class.